the aerospace industry, I mean, you couldn't get a concession on anything. It had to be absolutely spot on. And I mean, even the size of a chamfer, you know, a lot of the parts were over-engineered. A lot of the features were in fresh air, effectively.
Hello and welcome to another edition of the MTD podcast. Today this is another podcast that's actually being commissioned here at Fanuc UK's headquarters in Coventry on Anstey Park during their open house event. Today I'm joined by three gentlemen, actually one gentleman and two colleagues. I'm going to firstly introduce our guest from Robopod, Tony Parker-Watkins. Welcome to the podcast, Tony.
Thank you for having me.
Good. And also Mark and Gio. I don't know which one of you two wants to go first, but welcome to this podcast. Mark.
Well, it needs to be the
Always
Italian Stalin, really, doesn't it?
Less of the stallion. Gio, you good?
Yeah, very well, thank you, mate. Not too bad at all.
We've done loads of podcasts this week, so there will be a lot on the channel. We've had guests from all area of industry, also not just from Fanuc as well, of course, like yourself, Tony, from companies that are exhibiting here. Firstly, Tony, maybe you could just give us a brief about Robopod and your company and what you do, and then we can dig into the detail.
Yeah, so Robopod is part of the Mech Automation Group, and within the automation group we've got Mechatronic, that kind of built first of a kind equipment, special purpose machinery and robotics. Robopod is more of a solution, a robotic solution that has a portfolio of products within its range, so from machine tending to robot assembly to AMRs. And we kind of market Robopod as more of a smart factory solution, and we're slowly transitioning our bespoke side of the business through Mechatronic into that smart factory offering as well. And then within the business, we've also got MagServe, which is a service arm of the business, which kind of supports the service and maintenance and service contracts of our automation out in the field.
And give us a flavour of how big the company is.
Generally turn around about 10 million. We've got about 50 people on board. We predominantly sell into the UK and Ireland, but we have got installations out in America and Malaysia and Eastern Europe.
Okay, now before I know you've got something you want to ask, Joe. I committed a cardinal sin. I didn't introduce myself on this podcast, so I must say this is the first one you listen to. I'm Paul Jones from MTDCNC. So now we've cleared that one up, Gio.
Firstly, it's been brilliant to meet you guys this week, and it's been brilliant to meet so many different industry leaders in automation this week. We've all learnt a lot, and it's been really interesting. But looking at your product, it's quite unique, and there's a lot of unique features to your product. So I think that's a really good place to start, really. Why is your product unique? And you mentioned smart factories. What is this?
Okay, so Robopod, it was born of a time when I suppose Mechatronic was doing an awful lot of bespoke automation. We didn't have a product within our business, so we started off with Robopod as because it's one of the technologies that we're really good at, robotics. But really, what we saw in the first few years of Robopod, it's been going for 7 years now. We're in our third generation of pod. Was that the adoption that people really liked the flexibility, the portability of it. We started developing the control system because data was becoming king. Certainly in the last 2 to 3 years, data has been really powerful. So we've enhanced our control system on the Robopod so that we can start offering connectivity. And with the markets that we were serving in Ireland, certainly the medtech sector, connectivity was the massive buzzword. It was all about how can we get one process to the next process with the parts tracked and traced. So we started thinking a little bit more outside of the box into how we're going to offer our automation. So we offered machining tending systems. Robopod become more complex in some of the technologies that we're developing there, the robots that we're using. And with Fanuc, they've got such a broad range of robots within their range. We can put SCARAs in there, 6-axis, Delta robots, collaborative robots into our solutions. So with that full range, it's one of the reasons why we've partnered up with Fanuc on all of our pod products. It gives us a great opportunity for automation within some of these sectors. So we've got this pod. We've got our tending systems, we've got AMRs. So the AMR technology really did kind of grow the actual solution of flexible manufacturing, and that's where we've kind of our first flexible manufacturing.
Tony, can I stop you? Could you explain what AMRs are for our listeners?
Yeah, autonomous mobile robots. So that's where we've got a little, I'd say we partnered with Omron on that technology, which it's a robot which we can guide around a factory floor. It doesn't go on any wires or tracks. You can teach it, so it uses a LiDAR scanner to teach its environment, and once it's got its environment taught, it's left to its own devices to drive and from A to B.
So Tony, you're producing products in collaboration with FANUC. So FANUC are actually giving you the robots to a certain extent, and you're building that. Your products are built around that to a certain extent. Is that how it works?
To a certain extent, yeah. We've got that. Yeah, depending on what the application is, depends on what robot we use. So if we're looking at real high-speed technology or technology applications, then it would be like more of a Delta robot or the Skyra robot from FANUC. If it's a bit more of a complex application that we're doing, more assembly, multiple process within one pod, then we'd probably use a 6-axis. An alarm-mate type robot would be probably the preferred choice. But when we go back onto the smart factories, when we're linking pods to pods, they're using that AMR technology, that automated autonomous mobile robot technology, enables us to track and trace that product from one process to the next, guaranteeing that it's gone from one process to the next without a human touching it. And again, in that medtech sector, that's really advantageous because they know that the whole process and the manufacturing process isn't taking place in that part.
Two things. Firstly, I was hoping never to hear those words track and trace again, but we've all got used to. This is fascinating, this AMR. I've seen it in quite a few instances, not just in industry, but is it similar to what they're doing or rolling out in Milton Keynes, which you probably know about, where they've got these little autonomous things delivering food and all the rest of it?
Well, it's but more factory based.
Yeah. But it's the same
exactly the same principle. Yeah, and they've got different size payloads, different size units. I think they go from something like 60 kg payloads up to 1.5 ton.
Wow.
So there's quite a vast range of products you can carry.
And I don't want to go off kilter too much, but do you know much about the autonomous motors that I'm talking about in Milton Keynes?
No, is that no? Go on.
You don't? Okay, no, I just wondered about the security element of them. And you see these things going down the pavements. I know you two guys don't live near Milton Keynes, but when I drive through Milton Keynes, you will literally see these little vehicles going up the path, and they're delivering food, whatever it is.
How do they negotiate the roundabout?
This is the questions that I was going to ask, but if you don't know, I mean,
I guess that's a kind of similar sort of technology, but the actual AMRs that we're talking is very much factory bound. The way you teach them is that you would drive it around a facility. So you'd have a joystick. You'd drive it around all the corridors.
But as you're doing that, it's learning its environment, and it's knowing where the obstacles are.
That's exactly it. Yeah.
It's knowing where the hazards are. So I'm wondering. I suppose my point being, and we'll move off it, but I just wondered whether it's a similar principle with these things. So
I think they work off GPS as well.
Well, maybe they do. Yeah,
I think they work off satellites.
But how do you stop someone opening them, breaking into them? I don't know.
Again, that's down to the technology of how they've tooled the top of the. Because most of the units, it's the drive unit is provided by a manufacturer, or they've developed that themselves. But the actual tops tooling, that's where Mechatronic and Robopod come into our own, is that we do use a source for the actual drive unit, but the development of the tops and the automation on top of the actual AMR itself is designed and developed by Robopod in-house.
Tony, what I like about your solution, especially with the Robopod, is that it's very, very flexible. In other words, you could be talking to a customer with FANUC and actually producing a cell, as in the machine, the Robopod effectively, and making sure that delivers what customer. But also, I'm sure you can actually, hopefully I'm correct, that you can go to a customer and say, look, I've got this issue, and you could adapt the Robopod to what the existing machine tool is.
Yeah, we can. Yeah, absolutely. So if you're talking about machine tool, we've got Robopods, and we've got different scales and sizes of tending systems. So we've got a very compact system which is more geared up for tending of CMM type technology, up to the larger TenderPod XLs, which can tool. We've got them on Mazak 430As. We've got them on Robo drills. So there's a multitude of systems there. The beauty of our tending systems that's different to anybody else's is the footprint. We're only 850 wide by about 2 meters long, but we use a lot of head height speed, so we're about 2 meters high, but we're only 850 mil wide. And that's a massive, massive advantage when you start talking quite dense. When you look at a machine, real estate is king on a CNC machine.
If you go up, it's almost free, isn't it?
Exactly.
As long as the ceiling's...
Yeah. And by being that narrow as well, by having an M10 side robot, which is about 1.4 metre reach, we can actually reach two sides of the cell. So we can reach into a CNC machine on one side, and we can actually reach into a CMM on the opposite side. So when we're talking, again, I refer back to the medical device sector, a lot of the times in the orthopaedic sector we work in, they do it in batches. So they have to do a CMM measurement. So you'll put the first batch through, you'll take the first part out, and then you'll have to CMM measure the first one before you continue on with the batch. But by having a CMM and a CNC closed together with a robot in between, you close that loop.
Full control, basically.
Full control, and you don't have that the operator having to, or the associate walking down the aisles, going to a CMM, and potentially 20 minutes wasted by the time you get the part back. You can do it instantaneously.
It's automated inspection, isn't it? It's and it's something that we've been touching upon a lot, that some companies look at the inspection and the metrology part of the business as separate to the manufacturing, or they look at it as the production is making the money and the inspection is costing the money. But ultimately, really, you need to look at it as a complete process, don't you, Tony?
But I think you have to close that loop. And I know this is sort of what we were talking about then, but I've seen recently robots or cobots working in conjunction with, let's say, a Renish or a Quater, and they're only able to determine whether it's a pass or fail.
It's a comparator. That's a comparator, the Equator.
But for me, I think that's great. But what you want to do is, if it's a fail, you want to know what it's a fail and then put it back in and offset
GOM
it.
Inspect or the GOM scan boxes, they can give you data-rich reports that are actual visual reports as well, so that it can enhance your manufacturing process, because it's not loads and loads of code. They actually can see exactly where the
because
defect
the thing for
is.
me with what I'm talking about is, if one fails, the likelihood is then the majority coming through afterwards are going to fail. But what you need to do is intervene at that point, and there needs to be an intervention which then communicates back to the machine to change things. Which
change
I know things
offsets
do.
for outcomes.
So that's the whole idea of the closed loop, the CNC on one side, the CMM on the other. Close that loop so the offsets are provided automatically, and the utilisation gains on a CMM and a CNC is absolutely massive when you've got a robot there doing that instantaneously, and you're not waiting for an associate to.
Can you give any figures on that?
I haven't got any figures, but it's significant, and it's those small wins when you're in a competitive market for that type of industry. It's a massive win for them.
But how often as well do we go into machine shops and you see the guys there with their micrometers and verniers?
Yeah.
They're just part comes off.
I'm surprised you remember what one is.
I would say it's even worse than that. How often do you go into a CNC shop and you see a part on a CMM that's just been left there unattended, and it's just waiting for someone to walk past because it needs that operator to take that part off the CMM and then reload it with another part?
We travel the world looking at lots of different solutions for manufacturing engineering. We go to a lot of shows, obviously. Have you got a competitor? Because I don't think you have. No, not a direct one, anyway.
I've not seen anybody out in the market with the offering that we have, where we've got the opportunity to do bespoke automation and tailored, but then with the RoboPods, it really does differentiate us. Certainly with the pod and the growth of the different pod ranges that we've got with the robot tending systems, the robot in a box as RoboPod, where we can tool or utilise a multitude of technologies. They can be configured with laser technology, they can be configured with screw driving, they can do assembly, polishing is one of the applications that's been discussed today. And then the beauty of that as well with the pods, and it's something that we probably haven't touched on this, is that they can be reconfigured. So say in 3 years' time or 5 years' time, the application becomes obsolete or the product range has ceased, we can actually have that pod back. We can take out all of that technology and then replace it with new technology, keeping the robot, keeping the control system, keeping the frame. So the cost saving on reinvestment and reutilisation of that equipment is significant.
Now, for our listeners that might not be able to visualise some of the products that we're discussing, they can visit the MTD website and look at some of the footage that we filmed at FANUC this week, because the podcast's not going to be probably out for another 2 or 3 weeks at least. But with the RoboPod, we've just mentioned the RoboDrill as an example of a machine tool. We've mentioned the iTend, or your tending solution, in the middle. And then on the other side, you could potentially have your RoboPod doing a polishing application, a laser application. So it gives you additional flexibility or another automated process. So you're eliminating another process then, effectively, and you're just bolting it onto a cell.
Exactly.
Is that what you're trying to? Exactly. It's very modular.
Yeah, it's very modular, very flexible, and again, it's what we've termed the phrase flexible manufacturing. Again, with pods, why have all your technology on a linear production line? I think we've got to the stage where people want data, they want flexibility in the product, and they want the automation to do more. So rather than have everything coupled into a linear production line, like a laser, like a screw driving station, why not have them scattered around your factory and then have AMRs delivering them from one process to the next, but tooled up so that it can accept different product ranges, and that technology then can be used on a multitude of products that you're going through your business.
But you can also move the robopods to let's say, for instance, you've got a turning machine doing one application, and suddenly that stops, for instance, and you could actually move the robopod to another machine.
Yep, it's fully portable. So none of our machines, our tending systems or our robopods are bolted to the ground. They're all freestanding, so they're all pallet truck driven. The larger of the pods, which is a 2.1 by 2.1 footprint, that probably would need a bit of a fork because of the weight that's in there. But the standard pods we're using for exhibitions all the time, and you just push them around with a pallet truck.
So looking at the type of flexible solution you're talking about, making a comparison in some ways, I'd be interested to know opinion on this. It's almost like a panel discussion in a sense, but machine tool builders and solution providers are looking to make machines now that do everything rather than moving parts from one machine to another. But what we're saying is there is possibly an argument to both sides, isn't there, where you have lots of different machines moving parts using systems like you're saying from machine to machine rather than having one machine that can do all of those operations. Because you could have a machine that mills, turns, 3D prints, grinds, etches, laser cuts. You can have machines that do all that. But by having those disciplines or those processes in individual machines and then just moving the parts around is as possible, isn't it?
Yeah.
But it just depends, I suppose, coming back to your
I like the idea. How I'm thinking about it, and I used to, when I was in aerospace, we'd have a deburring department. We might have a fettling department. We've got a different department for this, or a cleaning department. So effectively, how I'm thinking it, you've got a deburring department in a box. You've got a washing department in a box. You've got, and effectively you just plug it into a machine tool on the side of it. So once it's done its machining process, it deburs it off there, and then it can be transferred to a measuring box. and it literally, it's kind of getting rid of a department that effectively will potentially done by a man, a laser or welding pod box. And it's like all of a sudden you just got these effective what would have been sections within your facility that not only are they in your facility, but they can be moved to wherever they're required within your facility and plugged into another machine to where it's required. I don't know if I'm right or wrong. That's how I'm visualising it.
Yeah, but my analogy, I know what you're saying, but what I'm trying to compute or get across is the fact that in industry for many, many years, people have tried to get away from having one machine and one zone that does one thing. They're trying to get that zone to be able to do all of the things.
All in one machine,
once. But what we're almost saying now is there is an alternative to that.
Flexibility.
And it's probably more flexible it is more flexible to do it in the way that you're
It's
saying.
flexible manufacturing, absolutely. And when you start trying to put up, in my experience of trying to put loads of technology and loads of processes, loads of product variation for a piece of automation, it becomes very expensive. So what you're trying to do by having these individual cells, you can actually potentially reduce the cost of automation.
And it could be an overkill as well. You may have this wonderful piece of technology that does everything, but then
you're only
you just
using
get
one bit
of
of
those.
it. Yeah,
Absolutely. That's £400 an hour. I can't put that on there.
But that's sort of factory of the future in a way, isn't it? Because it's quite easy to. I mean, how many times have we actually reviewed some machines, Paul, where really you could actually have one machine taking out three machines that do the same process effectively.
Yeah.
But when you're designing that new factory, because that's the part of your software as well, isn't it? You can actually look at the best way to actually plan the shop floor.
As part of the sales process, when we are actually collaborating with our customers, we do quite an intensive upfront discussion with the customer, and then we go through simulation. So before we've even put to paper in our proposal, we're kind of working out concepts in 3D, 2D, and then we can actually 3D simulate the concepts as well. And it's a real massive tool, because when we're selling to our customers, we know there's an internal cell as well, and they can use those simulations, those models to help to sell internally. So, and that's a really powerful tool. And we use, I'd say, probably 3D simulation software more as a selling tool rather than an in-house CAD modelling tool.
I mean, for me, I'm kind of looking at the broader picture in regards to the adoption of automation and emerging technologies. And like we've mentioned this week, there's too many engineers that have not adopted automation yet. What we're talking about is high-end, isn't it? You know, it's not kind of entry level. What kind of people are you selling to at the minute? And does it also lend itself to the smaller SME?
Yeah, we've sold pods to all sizes of business. from blue chips, which, some of the top aerospace manufacturers, to some small single units out in the field. So it's not really it's the application, really, I suppose we're kind of gauging, not the real size of the business. They are affordable. It's something that people can invest in.
Is there any government funding, grants or anything for stuff like we're talking here? Do you know?
I don't know of anything at the moment.
You don't come across that in the commercial world when you're discussing. Just
No.
be interesting whether there is any incentives to say, do you know
There
what?
should be.
There should be.
There should be.
Absolutely. One thing we worked with Aston University on a servitisation programme where we was looking to sell the capability of the machine and not actually sell the asset. So, but it requires for a company like us an awful lot of upfront funding from us, because we'd have to invest in that equipment. We'd have to supply it free of charge to the customer. They would pay a monthly fee and gain the output of that machine. But if we're talking the numbers and some of the numbers that we're talking, it'd be a significant investment for us up front. So to get some sort of funding to help support that kind of model, which would really benefit some. We had a customer on the stand today just talking about that very fact. I'm only a small turnover business. I can't really afford to go the capital expenditure that you guys. Can you do some sort of lease funding system on there? And that's the kind of conversation that we're starting off with some of these smaller businesses.
Well, so the answer was yes then.
But that's exactly what you mentioned earlier, Paul, in regards to kind of
it's
hiring
imperative.
your equipment out rather than a capex.
In every other walk of this industry, every board that we tread, whether it be a machine, a cutting tool, a work holding station, these suppliers will almost try before you buy in a lot of instances, or guarantee that they can do X, Y, and Z, or some of the finance deals that are available from some of our customers means they don't have to pay anything for 6 months or a year. It's knocking down those objections, isn't it, in the sales
I
process?
think I read somewhere, I don't know if it's factually true, it was a while back, 85% of motor cars actually bought through like a PCP.
Yeah.
There's not many people going out there with a lump of cash, are they?
No.
Not that you can get too many cars at the moment, new cars.
Yeah,
We did for a while offer that as an option. So we did. We offered a servitised model, but the barriers that we were hit with, one was location. So we could only sell into the UK market. It couldn't be a bespoke piece of automation; it had to be one of our standard products. But two, then when we was actually challenging it with the customers, they didn't want to actually go down that route. They said, "We've got the cash; we'll buy it outright." So it struggled to get off the ground really in the UK. But
And also there's a lot of other, we found this out this week, there's also a lot of other associated costs with the types of things that you do. If they're bespoke solutions, there's the engineering time, there's the design, and you can't get those things, they cost money, and
you would really struggle to get funding for a bespoke piece of automation. I think you really geared for the Robopod products is where that's where there's potentially an opportunity.
I mean, you mentioned in some companies. Can you give us some success stories, that you examples really, Tony, that kind of can, give us a flavour for the kind of results that you can achieve? I know you mentioned some medical companies earlier. I know we can't mention names, but
it's very difficult when you sign up to NDAs on a lot of the projects that we get involved in, because a lot of the stuff that we're dealing with is stuff that's not even out in the market yet, and that it's through process development. But I can go from kind of industry specific. So we've kind of worked with hydraulic manufacturers doing hydraulic valves, where we started off with an initial simple machine, but then they've looked into the pod and invested into the pod, and they've purchased production lines where we've got linear pods all in a row, but we've got through conveyors. And the reason why and we've got different processes going through each of the pods. So O-ring assembly, screwing, assembly of parts, testing. But the idea is that they can break away 2 pods and slot in another pod if their product range changes, or if they want to put another technology inside. And they like that flexibility. One of the other areas where it won an internal innovation award, and again, it's a major aerospace manufacturer, where we used AMRs to transport product from an assembly rig into a temperature control chamber for testing for 24 hours. And that saved hours of setup time for the customer. And again, we did a bespoke temperature control chamber. We did the AMR technology, delivering the product to there and automatically docking and connecting to the actual chamber. So it's just a couple of examples, and I suppose one of the other things that we get involved in an awful lot is proof of principle. So proof of principle studies. So we've got a production line at the moment for auto injection devices at the moment. It's probably the single biggest automated machine we've ever produced. But we've got a full Robopod type control system on there. And we started off with a POP study doing a little benchtop type systems, and then it developed into an order for a much larger, fully programmable assembly line. So there's one thing I would say what we get involved in. We get involved in an awful lot of different areas and different sectors. It's like being involved in how it's made on the Discovery Channel. you get to go. It's like you guys. You get to go and see a lot of factories, a lot of facilities, and see how a lot of things are being made. But it's a delight for me because I really get involved and love automation.
It's an honour, and I think that it's probably a good place to end this podcast, Tony. I think it's been fascinating to have you on. Can you just tell our audience how they can see some of these things, your website address, and any points of contact?
So we've just launched a new website, actually. So, it's on the MECTEC Automation Group. So, equally, you can, from a Robopod, you can go www.robopod.co.uk and mechatronic.co.uk. We've got a YouTube channel as well, and we've also got stuff going on LinkedIn and social media. So if you type in Robopod or Mechatronic, hopefully we'll pop up on there. We've got a fantastic team of highly skilled engineers. There's 50 guys working hard back at the factory. We've got the skill set, we've got the expertise coming up.
Manufacturing in the UK?
It's all manufactured in the UK, yeah, South Birmingham and Kings Norton. Absolutely.
No, it's brilliant.
Can I just make one point? I've learned something from Gio's past, actually.
Oh, God.
So you used to make parts for the airospace sector. Did that actually put you off air travel? Is that why you don't like going on an airplane?
It was one of the reasons, yeah.
Didn't have proper quality control.
Well, to be honest, what I did find with
that loop.
Well, the aerospace industry, I mean, you couldn't get a concession on anything. It had to be absolutely spot on. And I mean, even the size of a chamfer, you know, a lot of the parts were over-engineered. A lot of the features were in fresh air, effectively. And it was very, very... The quality control in aerospace is second to none. But with me making the parts to scare me.
Gentlemen, thank you very much for joining us on this podcast. There'll be another one, of course, weekly, the MTD podcast. Thank you very much, guys.
Thank you.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.